Hi, welcome back. If you're new to the channel, glad you found this video. Today we are going to discuss an important topic in supervised learning. Okay, let me ask you, when you open the mail today, you saw few emails in your inbox and few in your spam. How does the machine decide whether it goes to the spam or to the inbox? This is not regression, this is something else. Regression, what we saw in the last video was a number. Right? You give a set of numbers, it gives you back a number. But in this case, the machine has taken a decision whether it will go to inbox or it will not go into inbox. This is called classification. And this is what we are going to see in this video. Believe me, classification is another type of supervised learning. But honestly speaking, this will be encountered by you very frequently, much more than the regression. Finding out a fraudulent transaction on your card or even a doctor's AI tool flagging off a normal X-ray and abnormal X-ray, including the face unlock on your phone. Everything is classification. Stay tuned and watch till the end of the video to get a complete picture of what classification is. Classification has the same framework as regression. It has the same loss function, but completely different type of answer. In regression, we had numbers, and here it's going to be a decision. What is classification? Here you can see three examples I have given. First, whether the email is spam or not spam. House, what we saw there, we were given set of parameters and we gave the cost of the flat. In case of classification, what we are going to do is classify whether the flat had 3 BHK or not. That's it. Yes or no. And in case of a scan, again we will see whether it is normal or abnormal. So if you see +1 is yes and -1 is no. Okay. Regression, it predicts a number. Classification predicts a category. Yes or no, spam, not spam, true, false, 3 BHK, yes or no. Something like that. Output yi is a subset of +1 or -1. What the output was there in the regression? It was a real number. You gave the number, it returned number. But here you have only two outputs. It is either +1 or -1. In case of regression, what was the model we got? It was Wx plus B, right? Here, this is the model we are going to get. Got it? We will go deep into this part in the next coming slides. We see the examples, spam, not spam, more than 3 rooms. Here, that's what I was telling. It is either more than 3 rooms or less than 3 rooms. There is no number. It is only a decision. Abnormal or normal. Okay. One thing to remember, regression asks how much. Classification asks which one. That's the difference. How much gives a number, which one is a selection. Okay. The loss function for classification. If you remember, what you do in regression, we found out the predicted value and found out the difference between the predicted value and the actual value, and we subtracted one from the other, squared it, added all the figures which we got, and then divided by the number of entries which we had, right? In this case, there is no difference. There is no number. In classification, either the model got it right or wrong. That's it. There is no how far away from the correct answer was the predicted value. That we are not doing it here. That was we did in regression. We saw the f of xi is how far from yi. But in this case, it is only f of xi is equal to yi or f of xi is not equal to yi. There are only two options. Okay. So what we do here, if you see the loss function, I have written 1. If you remember, when we were doing the notation which are used in ML courses, we covered this one function which is very, very important. So this is the misclassification rate. 1 by n, function 1 bracket f of xi is not equal to yi. So what it actually, the formula looks little intimidating. What it is actually saying is count all the entries where the calculated value is not equal to the actual value. That's it. If it is not equal, put a 1. If it equals, then put a 0. Okay. So here if you see, you have 10 questions. Okay. So here the 2 are incorrect. So you add the 2 and then 2 by 10 is 0.2. That is the rate of misclassification. Simple. The formula, that's what it is. If it is not equal, then you put 1, right? Why we are telling not equal? If not, why are not telling equal? If it is equal, then everything is going to be 0. Then 0 is any number is going to be 0. You're not going to get the correct answer. So if you want to get the misclassification, we want to see f of xi is not equal to yi, and that gives 1. So 1 is the indicator function as we discussed in the previous video. F of xi means the model got it wrong and fraction of data points classified wrongly. Again here, if you see, the classification doesn't measure how wrong. It is not measuring how far away from the actual you were. It is just telling how many times you were wrong. Got it? That's the difference between regression and classification. Okay, now we will see how the classification model is got. The linear separator. What happens in case of regression? You have the WTX plus B, and the different model puts, the different algorithm puts different values of W and B to get the final model. Okay. The same thing is happening here. Only difference is we are going to take only the sign of the output. Okay, whether it is positive or negative. So what we are going to do is if WTX is greater than 0, the output is 1, and if it is less than 0, output is minus 1. So what it is actually meaning is we are going to take many points like this. Like what we took in the regression as well, we will take many points and put different values of W and B. So for every value of W and B, it will see whether the function goes above 0 or below 0. So it will just put a line in between at 0 and see which are negative and which are positive. So to understand in a much better way, let us consider the actual value is plus 1. Okay. So now the algorithm will put various W's and B's to reduce the misclassification rate to the minimum. Got it? For example, if you use a equation, I write sine 2 minus x. For example, if we assume this is a model. Okay, here, so what it will do, it will put all the x's values here, all the given rows it will give here, and then find out the signs. Again, it will do for another model. Again, it will do for another model, and see which model has the misclassification rate to the minimum. In case of regression, what did we do? We saw what is the loss which is minimum. That is how close was the predicted to the actual. But here, what we are seeing is how accurate the prediction is on the correct side of the actual value. Okay, that is the difference. So the model doesn't actually guess which side you are on. It draws a line and let the calculation decide. Got it? To summarize what we have done in this video for the classification till now, we are going to predict if the house has rooms greater than 3. Based on two parameters we have an area parameter and we have a price parameter. Okay, one model is going to be sine area minus 10. Okay, and the second one will be sine price minus 6. So what we are going to do here, in this case, any area more than 10 is going to be plus 1 and any area less than 10 is going to be minus 1. And in this case, similarly, any price more than 6 is going to be plus 1 and any price less than 6 is going to be minus 1. So we are going to see the misclassification rate of which model is minimum. Whichever model has the minimum misclassification rate will be considered the best model by the algorithm. Got it? So here model is sine WTX plus B. There in regression the sine was not there. That's the major difference. I'm sure you have got a hold of what classification is. And what we are going to do, like regression, we are going to do a hands-on calculation for the classification as well, so that the concepts just sits inside your mind. I hope you liked this video, and if you did like it, subscribe to the channel and click the bell icon, and I will meet you in the next video. Thank you so much. Take care. Bye-bye.